Okay, welcome to our Nuclear Fusion in a Star Explorer video where I kind of go through and explain the key ideas here. And like I said earlier, nuclear fusion inside stars is probably the most important key idea that we're going to get from this unit. It's the key question about how all of the stuff, all of the matter in our universe is a result of things that are happening in stars. So as you can see on mine, there are highlights. If you want to add those highlights to yours, it might not be a bad idea. I highlighted kind of the clues and the hints and the background information that's going to be very helpful as you move forward and as we move closer and closer to assessment. And there are some really important keywords and relationships here, mainly between mass and gravity inside stars, okay? And how mass and gravity relate to fusion inside of a star, okay? So one thing that we kind of need to discuss a little bit is the idea of E equals mc squared, okay? Einstein's famous equation, and how it relates to stars in astronomy. So if you don't know, the E stands for energy, M stands for mass, and C is a letter that we use for the constant for the speed of light. Okay, so essentially, what Einstein figured out is that if you take mass, okay, like an atom or anything like that, and you speed it up to the speed of light squared, you're going to get energy out of that, okay? Which was this kind of revolutionary idea of how energy, or I should say mass, can be turned into energy. And that's really what's happening at the core of these stars, okay? And the paragraphs help us understand that. So we've got a star. Stars are absolutely gigantic. They're made up of really light things, though, gases, mainly hydrogen and helium. Even though they're very light, there are just tons and tons and tons of atoms of these gases inside stars. And even though they're tiny, they also have gravity. Okay, so the more of these tiny things that you have, the more gravity there's going to be. Okay, and the more gravity, the more attractive force and speed that there's going to be between these atoms. Okay, now if these atoms of hydrogen or helium or whatever gas in these stars aren't moving fast enough, what they're going to do is they're going to come close to each other, and then they're going to be repelled by each other. Okay, they're not going to bump into each other or anything like that. They'll come close, and then they'll kind of get pushed away from each other. When they move fast enough, when they move to the speed of light squared, instead of moving away from each other, they'll actually come together and they'll fuse and become something bigger. Okay, so in order to make helium through this process of nuclear fusion, you need like 4 hydrogens. They smash into each other, and they make helium, along with a large amount of energy. Okay, and then it's kind of like a chain reaction. If there's enough force, if there's enough gravity, you can take a helium and a helium, smash them together to make something bigger, carbon, and you take carbon, smash them together, and that's what's happening on the inside of these stars, and that's what this game was supposed to represent. Every time you swipe, there would be a new hydrogen, which is more mass, hopefully making bigger and bigger things. Okay. So, when you would fuse things in the game, you get energy points. And that was supposed to represent the energy being released by this E equals mc squared reaction. Okay, so that's kind of the breakdown of what the heck is happening inside stars and how mass and gravity are related. Okay, so whatever observations you made, whatever correlations that you kind of put together between the game and what you knew about fusion, whatever you've got there is fine. If you want to change what your answers are based on what we just talked about, feel free to do that. Okay. Now, one thing that's important to think about, and you had to really think about this when you're playing the second part of this game, was the idea of, well, not all stars have the same amount of mass. And how does the amount of mass inside of a star impact the fusion and what the star can make and how fast it makes it and all that kind of thing. So, stars are born from these just super huge clouds, I could say. I mean, that's the only way to describe it to make sense, of lots and lots of hydrogen, lots and lots of helium, and then dust particles, okay? And whatever amount of stuff that's in that cloud, which we call a nebula, is the set of mass for that particular star. Okay, so some stars come from smaller nebulas, some stars come from more massive nebulas. Okay, and that's going to have a very big impact on the rate of fusion and how fast the star goes through its life cycle and what happens when it dies and stuff like that. So to answer this question, in the game, you were supposed to determine a way to simulate the amount of mass inside a star. To do that is the speed of swiping, okay? A more massive star has more gravity, which means the particles are going to be moving faster, allowing the fusion rate to go faster, okay? So in order to simulate that within the game, if you had a low mass star, you would be swiping slowly, okay, for those 90 seconds. If you had a high mass star, you'd be going crazy, moving up, down, left, right as fast as you can, okay? So hopefully you figure that out. If you didn't, go back and try it and see what happens, okay? So you had time to work with your partner, 90 seconds to go through this, and kind of figure out, what happens to these more massive stars compared to these low mass stars, right? Okay. So like I said, in this box here, when it comes to a low mass star, the gravity is going to be simulated based on a slower swipe, okay, compared to a high mass star. And when I did this for my low mass star, I got 189.5 energy points, okay? And the biggest element that I could form, I think, was magnesium-24. Yours might be different depending on what your definition of slow was. And then for my high mass star, when I was just swiping crazy fast everywhere, what actually happened is I didn't get to 90 seconds. I got to a minute. Okay, so there was 30 seconds left. I had 260 energy points, and my star ran out of fuel. It died. Okay, and I think I was able to form elements a little bit bigger than magnesium. Okay, so quite a big difference there between the mass and how it's represented and what it does to these stars. All right, so let's kind of make sense of this. Question number one, it says, if game over means that your star has died, which star dies first, low mass or high mass? Well, for me, my low mass star didn't die at all. I could have kept going. Whereas my high mass star, like I said, I didn't even have enough time to get to the 90 seconds. Okay. Now to relate that to real life, high mass stars, because their gravity is so strong and that fusion is so fast, they will go through their life cycle a lot more quickly compared to a low mass star. And it's because they have a higher rate of fusion. Okay, and they have a higher rate of fusion because they have more mass, and those particles are continuously slamming into each other, fusing bigger and bigger things. Okay, to put this into perspective, high mass stars still, their life cycle is long compared to our life cycle. We're talking millions of years long, right? Our sun isn't big or small, it's kind of right in the middle, and it has been around for about 5 billion years. It'll be around for another 5 billion years before it goes to the next part of its life cycle. It'll be in that part of its life cycle for few more million years before it ends up dying. So these lower mass stars, their life cycles are just huge, mind-bogglingly huge. There are some low mass stars that will last forever, essentially, because they're fusing so slowly. Whereas a higher mass star will burn through its fuel faster. I mean, it's still millions, if not billions of years, but they're going to go through their cycle. They're going to jump from main sequence to supergiant to supernova very quickly compared to those low mass stars. Okay. Question number 2. I think we kind of walked through that. How is this related to the lifespan of low mass, high mass stars? Okay. Question number 3. Think about the number of times you swipe during the simulation, as the number of times is related to the number of hydrogens in the star, which has more initial fuel to burn. Okay. And like we've talked about over and over, high mass stars have more fuel because they started out with more things, okay, and since they had more things, they have more gravity, the higher rate of fusion, okay, but just because they have more fuel doesn't mean that they're going to last longer because of how that gravitational attraction works, okay. And then the last one I think I've kind of discussed. Consider your answers to the previous questions. How can you explain why high mass stars, which has more mass, has a shorter lifespan? Well, it comes down to gravity, okay, and that whole E = mc squared. Higher gravity means a higher rate of fusion, meaning it's going to burn its way through its fuel faster. And if you didn't see it burn through faster, I would say go back to the game and try it again. Set the timer for 90 seconds and just go crazy for a high mass star to kind of see, it goes quite a bit more quickly. Okay, so that's that for the explain. Okay, watch this again, go back, take notes, highlight those key things in those paragraphs. If you have questions, just make sure you let me know, and we'll see you.